already taken out your lab that we started last class, go ahead and do that. We're going to be doing some comparisons. You either gathered data on the low incline, which was 4 holes high, or the high incline, which was 8 holes high. And what we want to do today is we want to make sense out of the data and then be able to quantitatively analyze that. So again, if you haven't pulled that lab out, do so now. Everyone's lab, the graph on the position time graph, should have looked the same. It didn't matter whether you were 4 holes high or 8 holes high. Every single one of the graphs looked like this. It had a curve to it, and that curve got steeper and steeper and steeper and steeper. So this tells me two things about the motion of the car. The first thing it tells me is the car was going in a positive direction. I know the car is going in a positive direction because my position versus time graph goes uphill or has a positive slope. I also know that it speeds up. And the way I know this speeds up is if you put your trace that line is getting steeper and steeper and steeper. Now sometimes it's more gradual, sometimes it's more steeper or sharper, but that tells me that the car was speeding up the whole time. And then we got to the velocity versus time graphs. Now the velocity versus time graph is a little more difficult to see simply because there was a lot of blur that happened with the video analysis. However, if you take a look, I have 4 different velocity versus time graphs here. When you look at the 4 different velocity versus time graphs, there's one that kind of stands out as being very different. So first of all, let's talk about those. The first 3, they're all very similar. They're all showing the same thing. Some of them have a little more bumps than others, and that once again has to do with how precise your dots were, but then also the blur factor that many of you experienced. Every single one of these say the same thing though. They say that my object is speeding up. I can tell because down here is my zero velocity or smaller velocities, and it's getting bigger and bigger and bigger and bigger. I also know that the velocities are positive velocities rather than negative velocities, which tells me I'm going in a positive direction. Now, if you look at the one down here in the bottom corner, it doesn't look the same. And this is because I had a student that gathered data. It sped up as it went down the track, and right here at the top, that's when it hit the end. When it hit the end, it stopped, so therefore the velocity was 0. But then, if you'll notice, it dips down into the negative region. And the reason it's dipped down into the negative region is because it started to go back up the track. Then it came back down the track and kind of bounced a little bit. And that's why we see this graph. Although that's not what I wanted you to graph, I think it's interesting that you can get that good of data from the VT graph. Now, at this point, you should have your slopes out. This is the slope from the VT. What we want to do is we want to do some comparisons, and I want you to compare with my B-Day classes that have already done this. So when you look at the slope of the high versus the low incline, if you were a 4 hole, then slope should be in this range. Now, if you'll notice, my unit is going to be centimeters per second, which is the rise unit, over second. Centimeter per second is the way I say it. So if you'll notice, in the 4 hole data, it was around 130, 120 in that range. Right here, someone came up with 167, so I sent them back to their video analysis to see what mistake that they made. They found that it was a scale mistake. Over here at 8 hole data, you'll notice that we had these numbers, and once again, these are pretty good numbers, and I had one that was a little bit high that they had to go back and take another look at. Now, what does this slope tell you? Every slope has a meaning. Now, we already know the object was speeding up the entire time. Didn't matter whether it was 4 holes or 8 holes, they both sped up the entire time. But what this slope tells me is that for every second, the 4 hole car sped up by 133 centimeters per second. So every second, it got faster by that number. For every second, this one got faster by a larger number. Okay, so if you look, it's about doubled. It's roughly doubled. So if I'm at 4 holes high, we double it, and that's around 8 holes high, and we can continue that process. So if it was around 250, 270 for the 8 holes high, what do you think it would be if it were straight down? Something to think about. If we're going to graph the position versus time graph for the high incline and the low incline, I've got it here on the same graph. Now, I only asked you to do one, but if you'll notice, the blue line is curving upward. The red line is curving upward. Both of them tell me that they're both going a positive direction and they're both speeding up. However, the blue line is the high incline. This one is getting faster, quicker. So it's because of that slope per second, it gets faster, quicker. On the VT graph, you'll notice they're both linear. And then the blue line again is a steeper slope. Okay, that is telling me that per second it's speeding up quicker. Now, every slope has a meaning, and the meaning of this particular slope is something called acceleration. So you need to take some time right now, flip to your vocab section, and the substitute can pause the video so you can get your vocabulary word written down. Our word is acceleration. Acceleration is the rate of change of velocity, and you can find this from the slope of the VT. You could have a positive acceleration. You could also have a negative acceleration. Don't get in your head, though, that negative acceleration means slowing down, because it doesn't. Don't get in your head that positive acceleration means speeding up, because it doesn't. We just can look at the slope and say whether it has positive or negative acceleration. Acceleration is going to occur anytime the velocity changes. So that means if the speed changes, you have acceleration. So if you speed up, there's acceleration. If you slow down, there's acceleration. Or even if you turn, there's going to be acceleration. The symbol that we use for acceleration is A with an arrow over the top. Again, that arrow tells me that there is a size and a direction associated with it. It is a vector. Now, once you have finished with your vocabulary word, we're going to be moving on to the paper analysis questions. You'll want to go ahead and add this to your table of contents, down the ramp analysis questions. And your job for, probably about 10-15 minutes is to work on the analysis questions for Down the Ramp Lab. Then you're going to glue it in. Once you've done that, you're going to submit the lab to Schoology.